Oh, where it is?
What happened was I hear people talk about modern politics. It's never been this bad. You didn't live in 1968. They were shooting each other in the National Guard. Chicago.
Put the executive airport in.
Yeah.
My favorite, you know, PR was just PR was we got a 5 o'clock in the morning. They took 2 guns. The hood, and we're here. You know, we're here. There's 200 guys.
Okay, folks, I think we're ready. We've got our AV equipment all fired up, ready to roll. Everything's ready. So I don't think we have any fun business to talk about in the regular meeting, so we're going to jump right into our presentation. And I was fortunate enough at our banquet to sit next to Paige, and he volunteered to talk about his accomplishments and some of the details of his 1,000-kilometer flights. And I immediately said yes. I didn't hesitate on that one. Really want to hear from Paige, and very much appreciate you coming out and talking to us.
Yeah, so. Thank you. So I didn't spend too much time putting these slides. So what it means, I would like to make it a little bit interactive, and there are things that I don't cover that much. But the idea is I'm going to talk about the 1,000-kilometer soaring flights out of Boulder. Tell you all my secrets. The secret is there are no secrets. I want to do a brain dump and just in time for the best part of the season. What I'm going to talk about really holds true for pretty much any long flight. And there are some Boulder specifics, and hopefully that's going to be obvious. I will try to point out some of those things. It's what I'm going to talk about is generally true, and it's really what I do. There is not one way to do it, but this is like my what I learned and how I do it and how I go about it. And stop me at any time if you have any questions. So let's just jump in. So this is what the overview of my presentation, and I suspect it may go for an hour, or probably maybe even more. Is everyone okay with that?
Bring it on.
Okay. So I'll cover the list of all the 1,000-kilometer flights and look at statistics. Then talk about just general problem, what we're trying to optimize, and then talk about some of the key factors: equipment, pilot, weather, plan, challenges, and then tips and tricks. That's just the general throw it all, everything that came to my mind that I didn't put in any other category. So let's just go up. So this is a list of flights. Again, it's a small, resolution is not great, but this is all the 1,000-kilometer flights out of Boulder. And I included like this one and this one, which are not quite 1,000 kilometers, but for all the practical purposes, they are like 1,000 kilometers. So just because they actually fit the same pattern, they're less than 50 kilometers short. But these are all the flights. So there are the first 1,000-kilometer flight was done by John Seaborn in 2004, and these are not only 1,000-kilometer flights out of Boulder, these are 1,000-kilometer flights out of Colorado. There are no other 1,000-kilometer flights anyplace in Colorado. So we are the ones that are doing it. So John was the first one to do it in 2004, and that was like a real big deal because no one has ever done it before. And so now it's 2019. And if you look at this list of flights, so from roughly, 2011, maybe there was 1 year that there was, up until now, that there were no 1,000-kilometer flights. But John Seaborn did twice, 1,000 kilometer twice. Bob Carl did it once. I did it 18 times. This is -2 to remove those which are not quite. Bob Ferris did one, and Bob Caldwell did one. So John, Bob's, and myself are the ones that did them. And so these are statistics. So this is the date. So let me talk about this. So this is the glider, handicap. This is the actual distance. This is the speed for that distance. And what we are talking here is OLC type of flight, which is a 6-segment type of flight. And I'll talk more about that. And then triangle, that's how big of a triangle it was. 2.5 hour speed, that's like the speed league on OLC. So that's this column. These ones didn't really have that statistics, and they didn't bother to calculate it. Duration is the duration of the flight. So this is the actual flight duration, the first column. The second one is the duration of the flight on task, after start until finish. Takeoff time, landing time. This is average thermal climb and average glide, L over D, and percent thermaling. So like this one was 23% of time John was thermaling at on average 5.8 knots, and he was gliding at 1/50. And whether ballast was used, so 100% of time, so some flights have it less than 100% of time. And then just the general comment, and then this column is the one that I like a lot, and that's essentially my very subjective score of the flight. So was it an epic flight or was it Olympic flight on that scale? So, and then there is also, I'll send a link to this spreadsheet so people can look at it.
If I may,
Yes?
how does a 1,000-kilometer flight get enough?
On a relative scale. And I'll show you actually.
Okay.
Then the link on Glideport, so that you can click and actually see the flight, the trace. The other link is on OLC. So so this is. I'm not logged in. Okay, let me pick another one that I don't have to log in for. I don't know. Let's look at this one because this is me. So here is the flight. So this is essentially the Santa Fe and back out of Boulder, and so that's that link. And the boundary is here and all that. So this is just the standard Glideport stuff. Go back. And then oil link, so that's what it is. So now let me point out few things. So first one was 2004, then Bob did it, and he actually did fly pretty fast on almost 150 kilometers an hour for the whole flight. And that was border to border plus. I think he went all the way to Taos into New Mexico, but then going north he went to Wyoming and back. And then I did it 2008, and it was in Ventus 1, 15-meter configuration, 100% water. Then this is the only one that didn't use any water reach. Now, looking from this perspective, to me, that's quite amazing. But you can sort of see, really this one had a really good, very much higher relative average climb, but really much lower glide. So this one has so the highlights in the spreadsheet signify minimums and maximums. So this one had the lowest glide interthermal, and this one had the highest glide on average. And this one had, for example, John's flight had the highest thermal climb, and so on.
That's
so
average throughout the flight?
Throughout the flight,
Wow.
6.8. But you see, like this one is the lowest, so I did it actually with only 4.4 average. What else? And so if you go through the comps, the fastest one for the whole, I mean, this is 1100 kilometers, was 158 kilometers an hour. And the fastest 2.5 hour segment on any of these flights is 180, and this was, so, and this is probably, I bet this was probably a very long downwind lag or something like that. And then you can see, I mean, the shortest one was actually only a little over 7 hours on course. And then the longest one was, where is the longest one? Let me, 10 hours and 11 minutes for the whole flight. And then the latest takeoff, which is really quite amazing, was like 20 minutes to noon and flying without water. So that was actually pretty good. Actually managing to make that happen. The earliest launch, was 9:50 essentially, and the latest landing was almost 8:30 before sunset. I mean, when the days are long. So the least amount of thermaling was 18%, and the most thermaling is 31. And then the notable things, like there is a year, I mean, they did 2015, nothing happened. I did have some flights, but notably, I don't really remember because that whole year is a blur to me. I mean, my son got born, so probably that also interfered. And this is last year, so this is the largest triangle, which is just under 1,000 kilometers. And so large triangles are really hard to do around here. What else? Oh, and there are a bunch of days, like 2016, there was a really good day when two Bobs and myself did 1,000 K on the same day. Wow. So these three. And I did 1,000 K next day as well, so they were back-to-back days.
Why did you even get out of the plane overnight?
Just sleep with it.
I get 3,000.
And just to go over, so here is a table of these statistics that you just looked at, minimum, maximum, and then you can see what the average is. So the average speed for the whole flight is 130, but sort of the slowest one is 120, and that's worth knowing when you're planning. And you can see, so average thermal, so it's kind of 5 knots range, and then you're gliding it on the average of 1/60. And these are all a little better than 1/40 gliders. So nominal event is 1/44. And so, and then this is also interesting. So this is really the histogram of when they were done in the year. So you can see, so this is none in April, early May, late May, so 2 in early May, 3 in late May, and then June, as you would expect, it gets better. And then July, early July is the best, and then until monsoon comes, and then pretty much everything stops, and then depending when it ends, you typically get maybe another shot at it. And there's this table that I'm going to talk about later. So, but that's really what statistics are. So all those flights are thermal flights. We don't typically do wave flights that are really long, and just by the nature of our mountain geometry, we don't get it. I mean, in these flights, I mean, you go into convergence and we have a really nice lag or even a wave. That's not uncommon. And there are also no downwind flights, and that's one thing I would like to do, but it's really hard, just from logistic perspective. Okay, and this I'll talk more. So that's really just what we, again, Colorado flights, it happens that they are all out of Boulder. So what's the problem? What we're trying to do, it's really how do you fly 1,000-kilometer flights, but the OLC 6 lag, it's not a triangle, I mean, it's really, that's very specific. So that gives which really means it's not pre-declared, you just go and decide what you're going to do in the air. But there are, again, it's not such a long distance, so it does have lots of constraints. Now, consider this. So this is like north, and this is south, and this is Boulder, and the mountains are here. So think of you launch, and you go into the mountains a little bit, and you go 25 miles to the north. And then you fly first leg, and you go to 55 miles south. And this is pretty much a beam Perry Park. And then you fly 110 miles to the back north. And so you are basically a beam out canyon. You're still in the mountains. So this is, what is it, the Halligan Reservoir? Or Lake Hattie, I forgot, I always keep mixing. But yeah, a beam out canyon. And you keep doing that. And you finish 25 miles out. So when you add all of that distance, that's essentially 600 miles. I'm just going to be rounding numbers just so we are there in the rough order of magnitude. Now, the notable thing, 55 miles out, if you take 5 miles per thousand, which is 1/30, so this is 11,000 feet that you need. So 11,000 feet at the far end out of Boulder, plus 6,000 to be back at Boulder, that's 17,000. So 17,000, 17,000. So you can do 1,000 kilometers as a local flight, never be outside the range of Boulder. So, and that answers your question, that would be my F flight. Okay. And that's actually on my list to do, to try to establish that far end of Wimpy spectrum. But it's actually hard, because you have to be, it's not just go 55 miles out, it's really being within the glide range all the time. So and that's actually hard, not easy. So, but once you start thinking about this, it doesn't sound that hard anymore. So yeah, it can be a local hot flight. So in the first order of magnitude, so let's talk about first principle. So if you're flying at 100 kilometers an hour, to do 1,000 kilometers, you need 10 hours. So when we're in the middle of the summer, I mean, you can launch it, you can start your task at 10. I mean, there are many days when there is good lift already at 10, and you can fly until 8 p.m. So no big deal. I mean, even if you fly 100 only, your average 100 kilometers an hour, that can be done. Then let's look at the climb. So 600 miles, if you do 5 miles of distance made per 1,000 feet of altitude, that gives you 120,000 feet of climbing that you have to do. So 120,000 feet of climbing at 5 knots, that's 4 hours of climbing. So you would be spending 4 hours just to get, in a sense, that fuel that you need to cover all of that distance. Now for cruise, 600 miles, if you are cruising ground speed 100 miles an hour, which is not really very fast, no, that's ground speed. So given our density altitude, our altitude and everything, that's probably, I don't know, 80-ish, depending how high you are, 80-ish indicated, maybe in 75. So that's not a problem. But so 600 miles at 100 miles an hour, average that gives us you 6 hours of cruising. So 6 plus 4, that kinda matches that. And yeah, so no big deal. The actual average from that table is about 1,050 kilometers in 8 hours, and climbing at 5 knots average for only an hour and 45 minutes, little less than 2 hours, but that's because when you're cruising at 1/60. And it happens that that cruise was exactly at 100 miles an hour. So the numbers that I picked work out. So really that's the problem. So how do you do it? So what are the important factors? And these are the factors that I consider really important, so everything that came to my mind. So equipment is number one, really important. So you have to have a glider that's good enough to fly fast enough, and ideally a glider that can take water ballast. It's not necessary, but that certainly helps because you're flying faster. But there is like club discuses or the 505. They're just perfectly capable of doing that. So again, ballast is optional, not necessary, but it helps. It's important to have good instrumentation, obviously, so you know where you are and where you're going. Oxygen, so all of those things are, you're going to be flying typically 14,000 and above. And probably the biggest performance improvement is a good system to any good P system to any glider. So that's really important. And pilot comfort is also important because you're going to, as you saw, on average, you're going to be spending 8 hours there. So you really shouldn't feel uncomfortable, or it shouldn't be draining you.
It helps if you're thin, so you can fit into an A cockpit.
Yeah. So the bottom line is you have to trust your equipment. Yeah. So yeah, I have a little drawback there, but
How much water do you consume during what would you recommend for a flight of 8 to 10 hours?
In terms of food?
Water.
I typically, I'm pretty well hydrated before I get in cockpit.
Yeah.
And I was going to talk about that, but then
Great.
this is good. Let's talk about it now. So I have a 2-liter Camelback that's behind my seat, and just it's super easy. So I would typically for 8 hours I would miss probably about I don't know, half a liter. So I typically take a little bottle in addition to that. That's what I consume, what my natural consumption is. So I'm not overhydrating myself. But the important part as far as water is also, again, you're at altitude and all of that. So I also take salt pills because you're sweating, and so like what endurance athletes would take. So that's really helpful. I don't take Gatorade or anything like that. I mean, that's too sugary. But salt pills actually help a lot and keeps you sharp. But the important thing about equipment is that everything should be really working. Small issues tend to have big impact in flight, and I think I've done most of it, so I know about those things. Try to take care of everything. So it should be in as perfect shape as you can get it for your especially long flight. So next factor, pilot, and the first subcategory there is pilot skill. So you should get to the point where you are really very comfortable and you're pretty much on an autopilot, climbing and cruising. So you're not really thinking as much about I mean, it's like driving your car. You're not thinking about it. You're doing small adjustment and it's just happening. Or like if you're stick shifting, you're not even thinking about how you're stick shifting, but it just happened. It's that level of just basic skill that you need. You also need, again, if you're flying with water ballast, then you should be comfortable with that, and be comfortable thermaling with water ballast, and knowing how your glider behaves and all of that. If you have a flat glider, what you do, I mean, I don't know how many, very few people actually, I think, use flaps, keep adjusting flaps when thermaling. I do that actually quite a bit, because that actually helps if you are, I tend to be on the slower side of things and pretty steep, and if you get a little gust, just putting it into landing flap it actually helps it if you're not just chasing it. So again, flying with, and when you have water ballast, that actually becomes more of an issue. So as far as climb, again, important skills, finding thermals, and not only thermals, but finding best thermals, picking the best thermals, assuming you have an option what you're picking, but that's another thing. Putting yourself in position so you have an option what to pick. But then also finding best parts of best thermals, and being in the very core. So in order to do that, you need to be really steep. I mean, it's really unusual. I mean, if you're like 30-degree bank, you're not in it. You can get another couple knots probably if you go to 45. And yeah, and the moving, and the thermal is going to move, and understanding really the structure and almost the texture of thermal and how it changes with altitude. That's helpful. And again, as you're climbing higher and as it widens and becomes larger, you can ease on the bank. But closer to the ground you are, steeper you actually need to be, because smaller it is. So, and you need to carry extra speed if you're, I mean, if you're like 1,000 feet above ground and you're trying to scratch out, obviously. But, then technique, speed control again. So constant adjustment. I tend never to be satisfied where I am, and I always, sometimes that's not that efficient, because sometimes I would move myself out of it, and then having to, so I would lose maybe 20-30 seconds, having to come back, and almost the whole circle type of thing. And the typical circle, I mean, you would be 25 seconds, that would be kind of there, between 20 and 30 seconds per circle. The other important thing is entering and leaving thermals, how you do it. Again, if you have a flap ship, you're slowing yourself down. With flaps, you're not yanking on the stick. Then you're doing a sort of opposite when you're coming down. That actually works best for flap ship, so you're kind of squeezing all the performance. When you're pulling up, and you're you don't really want to be slowing down, obviously, until you're in the thermal. You don't want to be anticipating and slowing down when you're in sync. That's around the thermal, obviously need that. But it's also when you are pulling in the thermal, when it hits that gust, you're getting two additional effects. You're getting a little bit of dynamic soaring effect, and you're also accelerating yourself to your climbing speed. So the glider doesn't, in a sense, the thermal doesn't have to accelerate, so you're making that whole climb more efficient. And that's actually hard to always get right, but again, if you're trying to squeeze all the performance, yeah, those are considerations. So now, as far as glide, know the optimal speeds for your glider for cruising, and I basically have 3 speeds in my glider, like the default cruise speed, super happy cruise speed, and not so happy cruise speed, and like 70. Slowing down to when I'm kind of sniffing for thermal with water. In my glider that will be 75-ish. 85 is not so happy speed. If you slow down more, actually, the performance difference, if you look at what the polar is, the actual polar, you are not losing that much between, like, for those those 10 knots. Actually, it's fairly flat at that point. So that's it's a mistake to fly too slow if you are concerned, which is actually hard to do. Then my default speed would be 95-ish, and then happy speed is 105. That's in my glider. Again, every glider is different. And then I do a lot of dolphining, and also I do a lot of when I'm just cruising, and I know I'm not going to stop there. I'm going for that cloud, but that cloud is way out there. But I would be just thinking of geometry. How do I go under that cloud so I get maximum distance under the part that I think is going to be lifting? And so I slow that. I mean, that's where I'm going 75-ish, and sometimes, I mean, if it's really good, then it's slowed down even more. But I typically it's kind of you sort of approach it from into the wind a little bit, kind of go diagonally. You don't really want to do too much deviation, but you do want to do that zigging and zagging. That helps actually, and that's why we get again on average. I think it was 1/16, 1/40 glider actually.
Are you zigging, zagging more than you're actually circling?
Well, yeah, because I forgot what it was, 20-something% of climbing versus it's 77% of cruising. So really, in the first hour, 3/4 to a quarter. So 3/4 of your time you're cruising and doing that zigzagging. Almost always, unless it's a blue hole that you have to cross, then that happens, and then you're going at really, depending on your altitude, the best speed for that situation. Yeah, so again, finding best route and following convergence lines. Visual judgment when gliding. So assuming no lift, it's really it's kind of game to play. You can always think, if I go to that cloud, given no lift, at what altitude would I end there? So and then you can just play that with yourself and kind of figure out and kind of learn about what to expect. But the key thing is always staying in the good working band. And a lot of times in Boulder here we have an inversion, and above maybe 13,500, 14,000, things are absolutely amazing and great. And below that, I mean, it just sucks. And it's kind of hard to get into that band. And to get into that band, sometimes like starting early before all of that sets up, kind of gets you to punch through, but then you have to stay in it. That happens. Not that, I mean, often. And the last one in the category of pilot skill, you should be comfortable landing out. So again, unless you're doing that super big 1000K. But landing out, again, no big deal. And then you shouldn't be really fearing it. You should more think, again, your skills should be at that level where you're not fearing it. You're thinking of it as an inconvenience with some chance of happening. And that's the mindset that you should have when you get into the cockpit, because it's always a possibility.
Yeah, how many times did you line up for those in that time period when you did all those?
Yeah, that's a good point actually. I meant to mention that. This table that we looked at, they show the successful
exactly,
case. The unsuccessfuls are not shown, but I would think, it's not that I just tried to do 1000Ks, but depending on I don't think last year I had any land outs, but like flying out to Boulder, I mean, there were years that they had maybe 2 land outs, or I mean, like landing out that long one, so I didn't count that. But like landing in different places where you had to call someone to get you. Yeah. So I would say my average is probably once or twice a year, closer to one, over all of the time.
So 26 aces and 10 to 15 landouts.
Yeah,
Something
yeah,
like that.
yeah, yeah.
Hmm.
So, pilot experience, so safety. I put that in pilot experience because it's not really a skill, but that should be just there. And the problem with safety is that the bad behavior that you get away with actually reinforces doing more bad behavior. It's kind of that's how it is, but yeah, don't do that. But sometimes it's hard to say, like especially when you are learning, is really what's normal and what's nominal and what you sort of gotten away. Well, I mean, and it's not that hard. I mean, if you have a plan B, which is a safe plan B, and there was no concern, and you are on the only downside if things didn't pan out, or that you're going to have to call someone, that's not an issue. But yeah, it's safety is again, everything should be looked through the lens of safety. Yeah. So the other thing is strategic planning. So that's really the next level up, and there is a bit of strategic planning that happens again before you go out, and then there is a strategic planning that and reevaluating that plan and replanning all the time when you are evaluating the year. So it's really important to be able to do things on autopilot, so you have your brain cells that are planning and replanning all the time as you're risk management, another important thing. And what I mean by risk here is not really a risk of safety, again, we covered that. What I mean is really your plan, risk of your plan A not materializing, your plan A not happening. And the risk management there is essentially what we typically say how aggressive you are. And that aggressiveness reflects itself primarily in how fast do you fly between terminals. And actually nowhere else, because you're still, no matter what you're trying to optimize, you're still going to try to climb as fast and as well as you can, but it's really that altitude to the next terminal, or am I going to be a little higher or a little lower, and that's what I mean by risk management. And that comes from experience, so there is really everyone has to discover that for themselves and what works for them. Another important thing that comes from pilot experience is shifting gears. Typically, unless it's that super wimpy 1,000-kilometer flight, you're going to be covering lots of ground, and you're going to be in different air masses. They're going to be somewhat different. There are going to be some blue holes. There may be overdevelopment, thunderstorms that you have to go around, and shifting gears is really adjusting that aggressiveness level and taking even the stuff that you had 10-knot terminal or 12-knot terminal, and now it doesn't look that good, but I need all the altitude that I can get, and I'm going to take 2 knots or something like that. So you really have to stay focused on the end goal. You want to stay flying, and sometimes that also means maybe even retracing back and staying in a good air or changing completely the plan. Local knowledge also comes from pilot experience, and is more of a local knowledge at wider scale. So where to go, routes, altitudes, land out options, and so that helps. how you cross like South Park and Valley, or where do you go like on wet mountains, and so it's sometimes most of the times on good days it's quite obvious, but knowing that and what works in general, even when it's really super good and there are clouds everywhere, so it almost looks like you want typically to take those well-known routes that work even on weaker days, because those are going to be better routes on a good day anyways. Weather patterns, again, knowing our convergence lines, where the house thermals are, again, we don't know that around here, but then when you start going out, that also happens with pilot endurance, really important. I didn't want to use the word stamina, like again, they're almost interchangeable, but endurance has a connotation that there is some hardship involved. So, but it's really important. It's and it starts with physical fitness. So you have to be able to sit in cockpit for that amount of time that we talked about. If you what it really takes is just maybe if you're jogging or biking or hiking, and just do that and be in your really best physical shape. It really helps. And you have to sustain mental focus throughout the flight. I mean, you're not going to have 5 minutes to relax, and I mean, you have to be thinking it, re-evaluating all the time. So your physical fitness is a really important factor in that. And also what it means is having food and water intake, and the oxygen obviously should be working. But food is really important. You should be eating during the flight, and you don't want to be tired. You're going to be making bad decisions. So.
What do you recommend for food right along?
I do all kinds of stuff, whatever I can grab.
All kinds of what?
Stuff, whatever I can, like protein bars, or those hiking bars, and sometimes I have like I don't do that because that's a little bit yucky, but I use when I'm hungry I would eat that. I have that as a backup in my cockpit, but like a running gel type of thing that you would suck on. So that type of, but it's again in my glider actually cockpit is small, so I have actually that restricts my options, so I cannot take a sandwich really. So I thought to take really nut bars, and sometimes I did that a couple times. I just mixed make my mix of like dry fruits and stuff like that, but then it's inevitable a mess in my cockpit because
Right.
I'm going to have to clean it afterwards.
Yeah.
So,
Mice. When you get back, you don't want
Yeah,
like stuff
yeah.
that's gonna get mice.
So water consumption, it's super important. And pilot mindset. So and this gets into basically sport medicine. So be in the zone. So you're thinking about what you're going to do next day, and you have it visualized. It's all that sports psychology type of stuff. So that helps obviously. I mean, obviously you can do it even if you're not in the zone, but I think there are very few flights that I feel I was in the zone, but that's the goal. Confidence again. It comes from everything that we covered so far, knowing that you are in control of all of that. First and primarily safety, and that's not something that you're going to really compromise at all. Again, gear shifting, so we already talked about that. And sometimes it's it's really hard because you are in the moment and everything is great, but it's sort of obsessive compulsive type of situation. One moment you're at the top of the world, everything is great. 5 minutes later, oh my God, I need to dig myself out. That thing. So obviously you're trying not to get yourself into those situations as much, and that's really this constant planning and pre-planning and visualizing and looking ahead. And we talked about be prepared to land up. I mean, again, if you're doing this, it's a possibility. Okay. Next topic is weather. Any questions so far? Okay, I'll just.
I have one comment regarding water again. I had somebody knock into my head a few years ago the fact that it's important to save water toward the end of the flight,
Mm-hmm.
because when you're cold, if you're cold at altitude, your blood vessels are squeezing the water out of your blood,
Yeah.
which you're peeing out. But then when you come down and if it's
Yes.
hot down here, then your blood volume expands. You can have a reduction of blood pressure. You don't think very clearly. So
Yeah.
replacing that water is
Yeah.
very important
Yeah. So,
when you heat up again.
yeah, that's absolutely true. So it's really you should land with a little leftover water. So basically, and 3 liters for this type of duration is about right. So I've been thinking about getting one of those 3-liter camelbacks. I just kind of keep using 2 liter, which I have, and another half a liter. But yeah, that's absolutely true. And before landing, again, you were really mindset where you're kind of everything while you're on this long flight, everything, and you're optimizing your speed and distance and whatnot, and everything feels differently now than you're trying to land. So really drinking before that, ahead of time, not just before that, but getting yourself in the best shape for that landing is also important, because you'll see, and I know that myself, I have to get myself into, I'm landing now, and yeah, I need to be super focused on that. And my landings after that long flight, no matter, I'm trying to do my best, but they are not, very rarely they are like speakers. So, and I mean, yeah, I mean, you land safely and no problem. And yeah, and also using oxygen, so when you're at lower altitude, so just helps out. Weather, next topic. So this is what I observed. So there are about 6,000 kilometers days per season, and every year. So we are not again talking about downwind flights. This is like the typical flights that we do here, and that assumes perfect execution. So for example, this year I done 2 flights. One was 700 kilometers, and the other one was 1,000 kilometers. I think that 700 kilometers, had I seen one thing, it would probably have been 900 kilometers, but I didn't see it. I got towards little later they got outside the band, below the working band, and then just as I said, I saw some gray clouds popping up, and so there was probably another couple hours of flying there. But yeah, so it assumes perfect execution. Some days are just going to be amazing, but this is like what theoretically can be done. So what's needed now? Number one, days being long enough. No more localized overdevelopment, so you cannot have large areas of overdevelopment. Obviously, you can have them in one quadrant or whatnot, and then go in a totally different place. And then have, I mean, some of these 1,000 kilometers were really, if you were standing on the ground in Boulder, it would be, oh my God, I mean, this is really bad. Hey, just launch, get going, and off to the south, going south to the southwest, and it's just amazing. And then you just glide back at the end of the day. So you have to have good lift, obviously, throughout the day. And as I mentioned, it's typically mid-May until monsoon, but the best part is early July. The most important thing in my opinion is whatever system for checking weather or looking weather is really observe it and learn from it and calibrate. And what I mean by calibrate is, for example, like you know what the forecast, what the blip map might have been for today, and you know what really happened. And then you look at the blip map for next day, for tomorrow, and then on a relative scale, you can say, oh, this is what happened today, so I know that this delta, and if you apply that delta to the day-to-day, what actually happened, that's actually going to be pretty accurate. So that's what I meant by this calibrate. And doing that, you also learn what really those charts, weather charts are really telling you. And it's never perfect. I mean, there are some really great days, but you're always going to do some hard work, especially if you're trying to cover large distances. Well, maybe for that maybe 1000K, maybe things can set up. But so what I'm going to talk about is really my empirical observation of what works best. This is not to say that there are not other days that are also 1000Ks, but these are the days that I consistently find to be the best days. So, and I'm going to talk about it in a sense in 3 layers. And in the first order, it's really actually simple. So, what you need to know, will it overdevelop? And that's my first question. And that's really the primary filter, actually. Before even I look at what's the lift going to be. So I look at overdevelopment. What I mean by overdevelopment is going to be a really widespread, so the lift dies down, or really large thunderstorms that you cannot really sort of go around, or maybe small one that you can sort of go around, but yeah, that you may not want to be doing anyways. In Boulder, so this is very Boulder specific. So the best days are these prefrontal days. Prefrontal meaning cold front coming in. And you can really tell what it is just by looking at the regular civil forecast. And in the first order, it's like this principle: if it's hot, I'm going. But then you want to see that temperature drop for next day, and you want to see mostly sunny. And you want to see low precipitation probability, and the day can be windy. Nothing wrong with that. You'll be working harder, but yeah. So here is an example. Oh, so this is the 2016 when Bob's did 1000K and I did. So you can sort of see this was 93 dropping to 87. So this is the day when we all did 1000K. This is the next day that I did 1000K. So you can, it's kind of really hard to see there. But you can see the precipitation. It's I think 20, this may be 10 or 20, and yes, mostly sunny. So that's what you want to look. And so if you look for something like this in the first order, 7 out of 10 times you're going to be right. It's as simple as that. This holds true for Boulder. And this is the 2000. So I just picked like some examples. This is a 2018, so last year when I did this big triangle, which is a little over 900-kilometer triangle, you'll see it's pretty much the same pattern. So I cannot really read that, but there is a temperature drop with lots of precipitation next day, and again, high probability, but that's really just the front coming through. Mostly sunny.
Sounds like Friday. It's gonna get this Friday. It's
Yes.
similar setup. It's gonna get.
Well, tomorrow looks good. Actually looked good, but it's not. Then today looked like probably today was good. So I mean,
Actually, the wind went west.
yeah, wind, and tomorrow is going to be really windy, but tomorrow is going to be overdeveloping actually, so that's a problem for tomorrow. I mean, like significantly.
I was
That-
thinking-
So that's in the first order, what I look for. So nowadays I'm in the mode that I really don't. I have very limited time, and if I know enough ahead of time, maybe I can arrange things so I can go, and I can go on a good day, and so I like to go on a good day. So I mean, this is really my first filter. Then if you want the next level of detail, then what I do, I use blip maps. And they use the NAM model of blip maps, so that gives us plus 2 days, so 3-day forecast. And the first thing that I look there is Cape, and that's directly related to overdevelopment, so that tells me what's going to happen. And then the other thing that the next most significant thing that I look at is height of critical updraft strength, how high our terminal is going to go. And the third thing that I look at is wind speed and direction. And this pretty much tells me everything. The terminal strength is going to be, the height is going to be related to the terminal strength. So if it's going to 18, 19, 20, I mean, it's going to be good. But I also look at this, it shows buoyancy shear ratio. And again, I don't really look at it, but it's kind of fun to see. So the other thing that I use is then on the day of the flight, I looked at the terminal soaring forecast, and I'll show some examples for all those days. So in there, I look for trigger time, and I look for freezing level, and those are the two main things that I look for. So freezing level, just if you're flying with water, you should know about that, what altitude is going to be freezing, and then I would load my glider accordingly. I almost always put RV antifreeze in my tail because that's such a small volume. I would put some early in the season, May time frame, April 19, in the wings. Then it gets expensive, but if you're going to carry water, I mean, put few gallons and calculate really what my freezing point, assuming like a linear mixing type of thing that it's going to change it linearly and kind of figure out. But it changes, and by doing that, maybe you're changing the freezing point by a few degrees. But I'm not sure if that has really any effect. But in the tail, it's important, so I would put really like pretty much, if it's going to be cold, I put half of it RV antifreeze. And finally, forecast chart, and I will show what I mean by the forecast chart there. So here's the blip map. So that's that 2016 where we had multiple thousand Ks on that same day. So this is Cape. So I guess everyone knows how to read this. So we are right here. So you can see the mountains. So we are about 40 degrees latitude. So these are the mountains. So you can sort of see that there is going to be, I mean, it looks like there is going to be stuff that's going to be building up later. And the blip maps give you forecast middle of the soaring day, roughly. So, but it's good enough to get the idea. And you see, I mean, this is all kind of blowing up really here. But going towards New Mexico, really, and these are Sangres here. And so it's kind of going to be blowing up. And then this is the thermal height. So again, we are here, so you can see a lot of white. And so this looks really good. So Bob Caldwell did essentially border to border. So he went all the way here and all the way back and then back. And that's actually a really good plan for this day. When you see something like this. This is going to be blowing up probably midday or later in the day, but it's really going to be working early during the day, and so Bob took advantage of that. And I'll going to show you this, a few more examples. So, and then you can see the wind is not too bad. Again, you don't want too much yellow. I mean, if there is red, then that becomes a real challenge. But or orange or red on the blue one. And but again, it shows really consistent lift throughout. So that's that day, and then again this soaring forecast. You can see the height, thermal height. I think this is saying almost 19,800 or something. I cannot quite read it. Time of trigger temperature. So when things are going to start, I cannot read that, but that's the other thing that I read from here. So it's kind of shortcut, but in the first order, actually it works well. So this is reasonably accurate. So I normally launch before this. It starts working always pretty much before it, but that's what I meant by calibrate. So you kind of observe, you do it once, and you sort of learn to trust whatever the model is that they're using here.
Is that the thermal soaring forecast, the National Weather Service product?
Yeah. So this is for Boulder
Okay.
specifically. Freezing level, I think this is saying 16.5 or something like that. Oh, let me see. Maybe read it on the screen. Time of trigger, that's 11. In time of the next thing is time of overdevelopment. So this is a point forecast for Boulder. So it says none, which is what you would expect looking at the Cape chart there. The forecast, the synoptic chart, and this is very typical what you'll see. Again, so we're about here. You'll see high pressure, which is kind of counterintuitive in other parts of the world. If you have high pressure, it's probably not going to be such a great soaring. But you have this cold front coming in, and interestingly, you have this trough. And if you see trough, yeah, that's a good thing. So, pretty much, it just by observing most of those really the best days, almost always have that trough. And it has to do with just the general buoyancy of the air. It almost feels like there is more rising air than sinking air, and it's in wider areas when you have a setup like this. So here again the flights of that day. So this is Bob going to New Mexico, going back to Wyoming and coming back. And so he went on Sangres here. I think no, he went on Wet Mountains. I mean, this is always interesting hop here. Come back on Sangre over Blanca. West side of South Park Valley, and then this is just kind of local almost. And I did go really. I was more, you can see more, so this is my way out. And you'll see typically, again, going out, you'll be more east, obviously, because you are not climbing the tops of thermals, you're lower in general. So you're keeping your options more open for landing out and stuff. And then just coming back, so about New Mexico, and then just did this type of thing. And Bob Ferris, I think he went this way, you can sort of see it, and then went way out west and then cut back with the tail, and came back with the tailwind.
Sorry, the reason the trough situation works well is because you have air from the high pressure area streaming into the low pressure area.
Yeah. And so this is from last year when it did this big 900 kilometer triangle, and this day actually didn't work quite how expected. So there was I wanted actually to go south first, but there was like a cirrus all the way, and it didn't. All the way to the south, and it looked bleak, but I launched, and then I saw way out there, kinda almost Owl Canyon. I saw some puffs forming, and I said, well, that's where I'm going. So I essentially went out north, and then out east, and came. Show you in the next slide. But this is pretty good. I mean, it's really, you see, it's you get Cape that's purple, like 90% purple with few little things. That's a really good thing. And you can almost see that, again, my plan was just looking at this was to go out south, but it's actually this part that worked well in the morning. What I initially planned was not good, but that was a flight that amazingly, when I decided to do that and started, everything felt in place. I mean, it was amazing from that perspective, because it almost never works like that. You always have to adjust. So, and that was exactly the plan, to go out to the east, I went almost to the Rollins here, and then there was, later in the day, essentially there was a big blow up in this area, which is exactly what you would expect when you look at this, at the Cape here. I forgot about that, because my plan was to go, but I kinda went as far as I would there. Again, very consistent. The interesting thing, let me actually mention, oh yeah, and there was quite a bit of wind, so this was a very slow lag going this way. The interesting thing, if you look at thermal strength, you see these blobs, like this one, and they sort of don't make sense. If it's really a high point, so why would that there be not good lift in that area? So that makes no sense. What's actually happening, if you look there and cross-correlate with Cape, that's the area that's going to overdevelop really by the time model thinks it's going to overdevelop, and the lift is going to be that by the midday than what the model was for. So even on a really good days, you are going to see these little like holes, and typically it's about high peaks, and that means it's going to blow there, but actually that's a good piece of information, and what it really means, yeah, go there first, because it's going to be really good there. And then you are on your way, then it's not so good, and it's really good later in the day. So I don't have that, again, for this day I didn't save that synoptic chart, but it's, you can sort of see what it is. So it was kind of tiptoeing this way, and then going downwind, and then going upwind, and big leg all the way to that overdevelopment and back. And let me see if I can read any of that. No, it's
You monitoring the radar on your phone?
no. It's really these days tend to be so. Again, I used to look at SQT, and what you normally want to see on SQT is like that Y type of shape. So dew point diverging from the temperature, and what it means is that upper air is really dry. Essentially, Cape is telling you that same information. So it's not going to be huge overdevelopment. It's going to overdevelop in very small localized areas just because it's so strong, and it starts sucking and everything goes up, and obviously it condenses and falls down. But it's because of that. So it's really you almost don't. So these type of days, you don't really need weather. It's all visual. And there are days when something radar would be absolutely great, but I don't use it. I'm not used to it. So that's in the second order, and that's really 99% of time what I really look. And most recently, I just started looking at SkySight, and this is just getting a little extra detail in terms of time progression, how things are going to develop during the day, where convergence lines are, and streeting type of thing. So I just started using that and calibrating my understanding of that model. So I'm not trusting it yet, but it's actually nice because you can sort of play through the day and see how things are going to move and make your plan accordingly. Okay, any questions about weather?
Do you take any of those, any charts with you, or notes, or anything, if you're making a plan, you know? Do you look
No,
at
and
that?
that's just primarily me. I make a plan, and
It's all in your head,
I'm going
you
to
take a
talk about that a little bit. But I make plan A, and then I make plan B as well, just if that is not going to work. So I make that pretty much day prior, and then in the morning, I really, just before I launch, I look at the sky with having that information in clear mind. So then decide, well, plan A looks
So
good.
that's your plan, you make the plan?
Yeah, make the plan,
And
yeah.
just, it's
Yeah.
all up here? and-
Yeah,
Okay.
yeah.
Kind of on that note, how do you do it from a task standpoint? I mean, do you have like A task, B task, C task that you have
So-
saved in your computer? Or?
So again, going back to the basic definition of the problem. So this is OLC. So you're not flying to a turn point. So
Yeah.
you're flying to a general area.
Mhm.
And so yeah, I know how far I want to go. But I also, because OLC is really nice, again, it gives you a lot of flexibility because you can just go and keep going if it's good.
Yeah.
But then you have to decide when you turn back. So you definitely, so sometimes I would just stretch it a little bit that way or this way type of thing. But you can keep it really flexible actually
Okay.
with OLC, so no big deal.
Okay.
So I think actually, yeah, so that's what I just thought. So based on plan option B, so flexibility to adapt and the plan, yeah, it would change. So again, you're not flying a pre-declared task to a point, so it's a lot easier actually, because the point that you choose may be in a sinky area or something. But having this information and flying on these days, you can actually make a really good task. I think I can make a good task to a point where you fly within 500 meters of that point and come back, like a traditional racing task. And again, these are the best days that we see here. And again, I wouldn't put like that point above Canyon City because it's going to be sinky there, but it may be just like if you're deciding for a task and how to optimize it, so you may put it really like on the someplace Manitou Springs or west side of Pikes Peak and then go back, and that type of thing, so you can give yourself. But I wouldn't, for example, put it on top of Pikes Peak late in the day because there's going to be some overdevelopment thunderstorm typically. They're almost for certain on a good day. So you need to know your expected speed again, and you can see these speeds. Again, they were between 120 and 158 or something. So it's not a huge variation, but you can plan how what your legs should be based on that, and you can know your own capabilities, how fast you can fly. I mean, if it's 100 kilometers an hour, yeah, then that's fine, and you can still do it. But you decide how far you want to go based on that. So phases of flight, and this goes to that gear shifting. So it's again, you're covering a lot of time as well as a lot of distance. So it's going to be very different. So early on, it's going to be in general, it's going to be weak, and the thermals going to be far apart, and so it's going to be hard work. You're not going to be able to climb very high, and so you have to take that into account, and you shouldn't be aggressive early on. Then middle of the day, everything is going to, it's going to be just great. No overdevelopment and things starting to build up, and you are cruising, and you are as aggressive as you dare to be. And then later in the day, things are starting to to die down, but at that time things are starting also to be more lined up, and you can be flying, cruising slower, and you're going to have a very, very long legs, but again, your indicated speed is going to be lower, but you're going to be making a really, really good speed overall. And then if you're trying to squeeze as much out of the day, then it starts being really, really hard. So there is really that get high, stay high later in the day rationale. And if you fall out of that working band later in the day, typically you're landing back or wherever you are. So what are some of the challenges? So I mean, this is I just put a bunch of things so maybe people can help me with adding more things. But it's never really what you plan as far as the weather. It all looks good and gives you really a rough plan, but when you're in the air, it's not going to be quite that. So you'll have to adapt. So that's the point. It may be a blue day, and actually, I tend to like those very strong blue days because around here they're never really blue. You're going to have little things that are, I mean, if you have good polarized glasses, you'll really be able to see them, and that's where the best stuff is, and so it sort of removes the clutter of all the misinformation that you may get if there are too many clouds. So there are some really, really good days. Obviously, if it's a blue day and you are starting early, as you should, that first part is going to be really hard. But then during the middle of the day is actually amazing. So other challenges are overdeveloped thunderstorms, virga, so that's not uncommon. So both days that I flew this year, there was quite a bit of virga. That first day it was a lot. It was all safe, but you had to work hard actually going around it, and yeah. And there was always a route around it. There was no, yeah, so. But it essentially boiled down to hard work on both days. Again, covering large areas, you're going to encounter different air masses. Typically when you're going north, as an example, into Laramie Valley, it's going to be windy, it's going to be very different. It may look the same, and I don't know how many times I got sucked up into the valley because it looks, it's so great here and it looks about the same, and it's not at all. And then you have to work hard to get back, and that really hop back into the coming back south towards Boulder is actually tends to be a hard hop.
Why is that? Several people have told me this before.
Yeah, you'll see really almost all that's. I'm not sure, but all those good days, it's always more windy there. So I think the wind that we get here is really because it hits the mountains, and it's sort of part of it turns into lift that we like. And there, because it's more flat and just by the nature, it tends to be more windy, but it's stronger as well. So yes, so that's one thing that I learned. So blue holes typically are going to, again, you may encounter blue holes if you want to make some long leg. So you may have to reconnect with another patch of clouds someplace, and yeah, that's not uncommon, especially going south. So like from General Pikes Peak, and if you are trying to go towards Pueblo and not stay in the wet mountains, there might be really amazingly good conditions, like towards Spanish Peaks, but there tends to be a blue hole there that you just climb as high as you can and glide at your best glide that you to make it over. So So how far do you want to go? So what if the day dies early, and that happens? That's most commonly the reasons for land outs are really you are too far and you can not quite make it, or you got stuck, or just overdevelopment, and you just have to land there. Terrain obviously is our thing, so you don't really understand it, how it all works. And in the mountains, you always need to be able pretty much to lie down. So there are not many good options. Class B, obviously we cannot really go east. I mean, when we say east, that really means northeast, and good days for going northeast tend to be in May timeframe. Come July, almost I've never seen a good day, and then you can get some later in late August and September. You get some absolutely great days there, but again, September is only days are too short, so 1,000K would be really hard. And PFRs, so we had some years when we had PFRs all over, and you just have to know about them, go around them or above them. Yeah. So tips and tricks. So this is like a catch-all for everything else. Risk management and statistics. Yeah. So again, if you're aggressive and consistently aggressive, some of those risks are going to materialize. I mean, that's really just what the statistic is. So so be careful about that. So that's actually, I think, one thing that I started doing. I become more risk averse. So risk management, this is not the safety risk again. This is the risk of plan A not materializing. So I'm now tend to make it easy on me, as easy as I can. And obviously it helps if you start early, then you can go farther, and you're going to work hard early, but you can go far. But it's also very important to go fast. So those are sort of conflicting goals. So it's kind of finding the right right point is a tricky thing. Let's see how the switch. I want to show this chart here. So in terms of risk management, so these are all those 1,000K flights. So these are the speeds for all of them, and you can really see the clear trend of overall speed coming down. And I think so.
Is this your flights or all?
So all of them. So this is John Seaborn. So again, this is Bob Ferris. This is me. This is John Seaborn again. But this is mostly me, and I think Bob Caldwell and Bob Ferris are someplace in here. But again, even if I took those out, it doesn't really make much difference. I mean, there is this clear trend, so kind of, which is really we used to do. So there, I think there are several factors. So one factor was that early on they were spread apart, and so when John did it, it was a really good day. When Carl did it, it was an amazing day, and so we did them just on really good days, and tended to be more aggressive. But the days were good, but so what I'm trying to say, in here there are some days that are not as good on average. So that's reflected in this overall speed. There is also so there is definitely an aspect of me being more risk averse as well. And then there is another factor, which is probably that now knowing how to do them, I also I'm launching earlier and staying longer, so I'm getting more of a bad part of the day, not so good part of the day. So that reduces the overall speed. So some of that is reflected, because I now tend to, I have one goal, I want to kind of do 1250, which is, I think, doable, but to do that, you have to really milk it out, and I've been doing that, and also even when it's clear I'm not going to be able to do it, I want to stay as late so I can learn as much about the day as possible. So that's also a factor. So, but this risk aversion is definitely reflected in this. And so tips and tricks. So the other thing is just in general, to make it easier on you, you want to do your first flag starting downwind. Obviously, the day is just starting; it's not great. So you want to fly the upwind leg later when the lift is better, obviously. So that would bias that baseline plan. Another thing is you want to go to those areas of overdevelopment that are shown really very. So I see Cape, be there and be gone. And another tip and trick is toe direction and start point. So based on that, you want to, knowing where you want to go, you just basically want to be in there and start flying for as long as you want, as you can, which means starting as early as possible. So you want to toe into the lift, number one, but you also are thinking about your start point. So say Boulder is here and they want to go north first. So in that case, I would typically toe to the south for the reason that assuming everything looks the same. If I'm seeing really crap to the south and really good stuff to the north, then I wouldn't be doing that. But everything being the same, I would go south, and that would be my start point. So number one, when you're doing that, you are maximizing your first leg distance, which is really important because again, we are trying to do 6 segments, and it's so the segments later in the day are going to tend to be smaller. The other reason why that's also a very good idea is basically you're flying across Boulder, so you're not so concerned about landing out because if you're just going to come back and you just did a long dart, but if you want to go north and you are already then you don't really have that option, but it gives you that option, feeling the air, learning, and really being reasonably aggressive, safely aggressive, safely in terms of the risk management early on. So phases of flight, so already talked about that. So again, hard work early on, and typically great, but you still need to maintain the same mental focus, and you want to be really making as much distance during that time. You want to be really maximizing the day all the time. And milking it at the end of the day. And so late in the day, we around here have a convergence, and that's really probably the easiest actually part of the flight. Again, given the OLC rules, you can do this. It's kind of goes into that wimpy category, but you can do it, and it's a fair thing to do. But it's not going to be an epic fight, and it's going to get, I don't know, not an egg. So what happens, you get the convergence or really weak wave, and for a really large area, and you can just sit in it, and it's so beautiful, and you're watching sun coming down, and you're just cruising and enjoying it, and going slow. And sometimes if I really need to get even more distance, and the day is dying, and it's really, again, almost no lift. There is this teeny tiny bit of left, and I find it, I would dump my water and just climb up, because assuming there is enough of the day to to still make the distance that I may get from that. So again, that's really in that milking it category. You want to maximize the first flight distance. That makes the whole thing a lot easier. Then it gives you a lot more flexibility what you're going to do and change your plan. If you have to go around overdevelopment, obviously, what it usually most of the time means is really going west. You always want to go around it on the upwind side, because going downwind, you may be able to get away with it, but if it doesn't work, you're landing out typically. So yeah, going around overdevelopment is not unusual and uncommon. So that's again, essentially we talked about time and weather development or overdevelopment, and if you see things building up and that you're not going to make it or you're going to be late for it, yeah, don't try going there. Or if you see, again, it goes to there are all kinds of considerations there. How aggressive you want to get. If you go fly faster, can you make it? If you're just push the nose down. But yeah, there is a lot of that I do. So I just watch what's happening and just at that tactical level, really adjusting where I'm going. And this goes to that endurance and being fresh for the whole flight. I now pretty much rig the day before. I don't want to be assembling my glider, and then from two reasons, I'm going to be tired and I want all the energy I can have, but also everything that I find that's wrong, there is really no opportunity to fix. So I typically would rig and fill the water day before and just park it there, and then it's I take care of those little swags that I found the day before when I rigged it in the morning. I may fill the oxygen things, that type of thing, but I'm not doing anything major. Incremental learning, that's super important. So everyone is at a certain level, but yeah, I mean there is a lot in this, but you learn little by little, and the other important factor is learn about yourself, and that's most important because number one, safety is going to come from that, and yeah. Go where it's good again. Yeah, don't be preset on whatever the task it is. So again, that's the OLC flexibility that we have. We talked about 2 days. Again, we don't get those very often when it's so strong, but we do get some. So where to turn when you make your turn point to be coming back. Again, I've been talking about a lot like it's more north-south, which a lot of time it is, but whatever it is, so you're going obviously into the wind or downwind, whichever way, but for OLC flights, it's really easy because you can get to the edge of that cloud or get to that last cloud and then turn, and then obviously you want to be, if you're going upwind, you don't really, again, you don't even need to worry about turning upwind low, the typical things that you would do, and going down, turning downwind high, because OLC, you just go to that last cloud, last terminal, and you are climbing in it, and that's typically your turn. So again, it's both upwind and downwind, so you're maximizing it. So it becomes easy, but kind of I used to do that more in the past, that I would get to that last cloud and then And I do that to some degree still. If it looks, it's kind of the street that's kind of still building up, and that there is more stuff there. Yeah, I would go out in the blue, but more often than not, you're at the edge of good air when you're seeing that. When to leave terminal, that's always, again, you need to be fast, so you don't want to dawdle around. So when it starts, again, if you're in the happy mode, then don't go to 18 or 75 and go to, well, 16.5 or 17, and you're just going to be bumping it along, and you'll be in 75 soon enough, just bumping it along. If you're under good air, so it's really, you don't really want to overstay. Again, when to terminal, being in that lower part of working band, but not lower than it, that's really important. So as closer you get to that, slower you should be cruising, obviously, but slower your speed is going to be. So you really want to avoid putting yourself in that situation. And end of day uncertainty, so that's also a big one, because again, you're trying to squeeze as much time out of the day, but also if you're doing this milking back and forth, north-south, that's actually really, I mean, again, you're in the gliding range, and it's like super easy. So, but if you are kind of doing out and return, that's a big deal. That's super important. That's it. Questions?
I know you mentioned dolphin flying earlier,
Yeah.
but when you're not dolphin flying, are you flying like a set McCready, or is it more just gears that you kind of have in your mind?
Yeah, it's those like 3 speeds, like default, happy on that.
75, 85, 95 kind of?
Yeah, so 85, 95 kind of.
105, yeah.
Like,
With one, without
with
one.
water, without
yeah.
water, it's
10
about
less.
10 less or so. Yeah, again, it's you don't, I mean, like a couple knots are not going to make a big difference. It's really making a little turn to be in a little better lift makes a bigger difference.
Yeah. It sounds like a lot of energy line flying versus
Yeah.
traditional
Yeah,
cruise
absolutely.
thermal, cruise thermal.
Absolutely.
What motivates you after 20,
Yeah.
1,000 kilometer flights to
Well,
get
I'm
out for
always
the
trying to
21st one?
to do different things. So it's as I mentioned, I like to establish that upper limit of wimpiness as well. But yeah, I want to do 1250, and that's hard. So it's that's running against our limits.
Well, you've done interesting things. You went all around the 10-way airspace.
Yeah,
That's
yeah,
all those
yeah,
flights.
yeah. So I have a whole list of things that I would like to do. Yeah, and I definitely would like to do a 1,000-kilometer triangle. Again, that's hard. Again, given our geometry, I mean, there are really 2 choices. One is like that flight, and the other one is kind of doing the mirror image to the south. So.
How much experience did you have before you did your first 1,000?
When did I do it? It was like 2008, so like 8 years or so. No, wait, 9 years.
How many hours?
How many hours?
Oh, well, really, ours wouldn't be meaningful because I did so much instruction. So there were lots of instruction hours, which did not help you in that sense. So I probably had a couple thousand hours, but it was a lot of instruction hours. Several hundred hours of instruction for a bunch of years. So.
Very good,
Very good.
No, thank you so
Thank
much.
you.
Thank you.
Yeah, that was fantastic.
George, anything